Well, hello everyone, and welcome to our channel 361 Physics. And here we are presenting our second video related with electric circuit and electric current. And this particular video is basically based on the solution for different circuits. So before solving different circuit, we have to recall some fundamental formula. So as we know that if we connect resistance in series, then the equivalent resistance will be the sum of the resistance of individual resistor in the circuit. That means if we connect the resistance uh, in series, then and its value are R1, R2 and R3, then their equivalent resistance is sum of individual resistance of the circuit. And if we connect resistance in parallel, okay, this is kind of parallel combination, then the equivalent resistance will be uh, reciprocal of equivalent resistance will be the sum of reciprocal of individual resistance in the circuit. So basically we have to know this formulation, and then we can easily tackle the questions. So now we are going to solve some MCQ. The equivalent resistance between X and Y of this circuit is, okay, so first of all we have to analyze this circuit, and if we make this circuit easier, then we can see that from uh, this point up to here, 10 and 10 ohm resistance is in series, okay, and this resistance is in parallel combination with this particular 10 ohm resistance. So it can be uh, simplified as this is 10 ohm and this is X terminal, this one, and then after we are here, okay, so from here there are two branches. So this is the series combination of two resistances, 10 and 10, and then after uh, okay, so it's another terminal is here, that means this point, and it is connected with another resistance, this is 10 ohm, okay, and then this is terminal Y, and the bridging between this point and this point is done by another resistance having value 10 ohm. So this is uh, the simplified form of this particular circuit. Okay, so we can easily see here that these two resistance are in series. That's why we can replace this resistance by its equivalent resistance, and that will be that will be uh, 20 ohm, okay, and then we can easily say that 20 ohm and 10 ohm is in parallel combination. So by using formula we can calculate the equivalent resistance of these two. We have direct formulation for two resistance in parallel combination, that will be R1 times R2 by R1 plus R2, and 20 times 10 by, and this is 30, okay, so we can write 20 by 3, okay, so for these uh, two, okay, these two, well, for these two, now we can replace their combination by a resistance having value 20 by 3, okay. Now these three resistance seems to be in series, that's why we can directly add all of these value, okay, so the equivalent resistance will be 10 plus 10 plus 20 and by 3. So it will be if you take here LCM, 30 plus 30 plus 20 by 3, and its value is 80 upon 3. So our answer is option C. Now we are heading to towards the question number 2, the potential difference between point A and B. So here are the points A and this is B. We have to find the potential difference between these two. If we analyze the circuit, we can easily say that uh, 5 5 5 ohm are in series and another 5 ohms resistance are in series, and the battery is connected in parallel with these the combination of these 3 and 3 resistance. So we can simplify it as this is our battery and here are 3 resistance having value 5 5 and 5. Another 3 are here and their values are also 5 5 5, and this is point A and this is point B, so its value is 2 volt. Now I'm going to find out first of all the current moving through this branch. Okay, so we know that the uh, combination of these 3 is parallel to the source. That's why the overall potential of this point will be 2 volt. That's why we can easily write, if I is the current passing through this branch, then I times 3 5, that means 15, will be equal to 2. Okay, so B equals to IR. Here we have used the Ohm's law. Okay, so I will be equal to 2 by 15, and then we have to find the current the potential difference between these 2 points. So the resistance of these 2 point is 10 ohm. Again we can use Ohm's law. B equal to I times R, and the value of R is 10 and value of I is here 2 by 15, and this is 10. So 5 3 is a 5 2 is a 2 2 is a 4 by 3. So option is C, correct option. Okay, now we are here in question number 3. The effective resistance between X and Y in the circuit is. So this is quite easy. If you see here, these 3 4 ohm resistance is in series combination and the equivalent resistance is in parallel with this 4. So we can directly solve it as 4 3 is a 12 and this 12 is parallel with 4. That's why R can be written as 12 into 4 by 12 plus 4. Okay, so it will be 12 times 4 by and 16. 4 4s are 4 3s are, so answer is 3 ohm. Okay, now we're heading towards question number 4, and the question is again same equivalent resistance between A and B. So here we can easily see that these 3 are 1 2 and 3 are are uh, these 3 are um, sorry these 3 are in series combination. So for these 3 R, we can easily write the equivalent circuit as this is R, this is R connected with branch A, this is R connected with branch B, and this equivalent resistance for 3 R is thrice of R, and these two resistance are in parallel combination. So again we can calculate the equivalent resistance of these two, and that will be R equal to, okay, uh, 3R times R by 3R plus R. This will be 3R square by 4R, so 3 by 4R, 3 by 4R, and its equivalent circuit will be like this. Here we can replace the resistance by 3 by 4R. Now we can easily see that these 3 are 3 by 4R and R are in series combination, then its equivalent value will be r plus 3 by 4 r. Okay, 3 by 4 r. And if we take here LCM, it will be twice of r and then thrice of r by 4. 4 to the 8 r plus 3 r by 4, so it will be 11 r by 4. Its answer is option C. Okay, now we are heading to the question number 5, and here is given the value of resistance R in this electric circuit given below. We have to find its value. So just as we know, these three resistance are in parallel combination. That's why potential of these and these three branches will be same. Here the value of current is 6 2 and overall value of current is 11. That's why the value of current here will be 3. Okay, and if you find out the potential, 6 1 the 6, here is 6 volt, 3 2 the 6, again 6 volt, so it must be 6 volt. So here is 3 ampere current, that's why its value will be 2, because 3 to the 6 volt, and these are in parallel combination. So option D is correct option. Okay, now we're here in question number 6, and in question number 6 it is given that same thing, the equivalent resistance between terminal P and Q we have to find, and the next thing is given each resistance has the value of 24 ohm, so we can easily find it by solving the parallel combination. We do not have to um, what do we call, we do not have to use the formula, just use the concept. As we know that in parallel combination of two resistance, it will reduce the resistance by half. So here the equivalent resistance will be 12 ohm, and in the parallel combination of equal resistance having 3 in number and they are connected in parallel, then the resistance, equivalent resistance, will reduce by 1/3. So 1/3 of 24 will be 8, and here the equivalent resistance will be 1/4 of 24, and that will be 6. Okay, so now we can easily imagine it, these three as the series combination of 12, 8 and 6, that will be 26 ohm. Okay, so option A is correct option. Now we are heading towards question number 7, the equivalent resistance of the circuit. Same question. So let us analyze this. If you see here these 2 points, and if I am going to write here 1, and this is just a wire, that's why this point is also 1, and if I am going to write here 2, then this is just a wire, that's why it will shift the point here. Okay, and then if I just take this resistance and write here as 1 and 2, this is uh, resistance, uh, the resistance of this part, and then easily we can say that for this resistance here, uh, one end is connected with 2 and another is with 1. Okay, so for the resistance, one is connected with 1 and another is connected with 2, and for another resistance, this third resistance, same thing is happening here. One end is connected with 1 and another is connected with 2. So again, one end is connected with 2 and another is 1. So the simplified form of this combination is the parallel combination of three resistance, and the resistance having the equal value, that's why the value of or equivalent value of resistance will be 1/3 of original value or individual value. That's why the answer is option B. Well, this is the solution for question number 7. Now we are here in question number 8. A uniform wire of resistance 6 ohm is folded to form an equilateral triangle, then the resistance across the side of a triangle. Okay, so initially the overall resistance is 6 ohm and it is made a form of uh, uh, equilateral triangle. So this is 2 ohm, this will be 2 ohm, and this will be 2 ohm. Now we have to find the equivalent resistance across any side. I am going to suppose the side to be AB. Okay, so if we analyze from this side, we can easily see here that the resistance, suppose this is C, the resistance from A, C, B is in series, and the series combination uh, is connected in parallel with this 2 ohm resistance. That's why we can easily say that the 4 ohm or its equivalent circuit will be like this one. Okay, this is 4 ohm and this is 2 ohm, sorry, this is 2 ohm and this is point A and B. Then we can easily find out the equivalent resistance. It will be 4 times 2. Okay, because these are parallel combination. 4 plus 2, 4 times 2 by 6, 2 3s are, yeah. And if you cancel out this, then it will be 1.3 ohm. So option B is correct option. Now we are here in question number 9, and the question number 9 is related with ohmic and non-ohmic resistance. Before solving this, we have to understand what is ohmic resistance. Those substances which follows this graph, or which follow the relation B is proportional with I, that uh, substances are known as ohmic resistance substances. Generally metals can show ohmic character, and semi-metals or semiconductors uh, do not follow this rule, because as we know that for junction diode or simply diode, if we increase the voltage for a particular voltage up to a particular voltage, that is known as knee voltage, the current shown will be zero. Okay, and after this, after exceeding this particular voltage, the current will gradually increase, which means the semi-metals or semiconductors do not show this kind of behavior. That's why that are known as non-ohmic resistance. So we can easily say that copper is metal, platinum is metal, tungsten is metal. That's why option C is correct option. Okay, now we are in last question of this particular video. At 0 Kelvin, germanium behaves as. Before this, we have to understand something for metals. Okay, for metal, let it be. For metal, if we decrease the temperature, resistance will fall down, and the metals behaves as superconductor if its temperature tends to 0 Kelvin. Okay, and if the temperature of semiconductors gradually decreases, its resistance will increase, and for temperature tends to 0 Kelvin, the semiconductors like germanium, silicon will behave as an insulator. Okay, so it's option B is correct option. Well, this much for this particular video. We are making lots of video, so please subscribe and stay tuned. Okay, thank you for watching. Thank you.